Here I'm talking to a student, and again, I'm using the equation pane to demonstrate something that I've highlighted an equation there I wanted him to look at, that the total energy was the sum of the translational and relative kinetic energy. And notice I've been fairly explicit here, where I gave a pretty big indication of how to find k total on the equation pane by summing the three kinetic energies of the particles in this problem. So it's kind of a question sometimes how much information to give the students, and I would say in general, give them what you think they need. So if they have almost everything, but they're not calculating it right or something like that, then you don't need to be all that explicit necessarily. Just try to figure out what's the one tiny thing they're missing. But if they kind of don't know where to start or how to approach the problem, then it's okay to be a little bit more explicit. The equation pane is really useful because you can write something up there and it stays there, unlike the text window in which text comes and goes. But if you put something on the equation pane, they can look at it and stare at it for a while and think about it, and eventually it'll make sense to them. Or even better, after looking at it for a while, they'll think of a question to ask you about it, and then you'll be able to clarify what you wrote, and they'll reach a fuller understanding of it. So here the student's asking an interesting question. How come we don't need to use the rotational energy for one particle? Well, you don't really need rotational energy for one particle. That'd be measuring the rotation relative to the center of mass, but you'd only want to do that for the if you're looking at the entire system. A single particle just considered by itself, you don't really need to think about its rotational energy. And it looks like he's figuring something out there. All right, here I'm checking the answer key. And I opened up Mathematica so I can really check something. Here I'm doing the force that's given, which is 133 newtons minus gravity, and then I can see that's the same as what was on the answer key. Sometimes it's good just to run little quick checks. It only takes, maybe 15 seconds or something to check it, and then you know that what you're telling them is airtight. Okay, now a student asks about how to find the work done by gravity. All right, well, it's definitely going to be some force times distance kind of thing. But I don't want to just give away what distance to use. See, in the picture, it could be h or d. Now, clearly, gravity is acting over a distance of h, so I just wanted to make sure she has that. Okay, she's got that. And there's the additional complication that they might mistakenly put a positive work for gravity here, but since the object is moving up, the work done by gravity should be negative. So I try to anticipate sometimes the problems that a student might have. Now, sometimes when they get it wrong, it's just a silly calculational error. So it's a good idea to pull up their answer key, which you can do on WebAssign. And a lot of the questions students have will be of that nature. I don't know what I did wrong. I calculated it. I think it should be right. Okay, so here I go to WebAssign, and I look at the scores for that particular assignment, and I find the student that I'm talking to. And then I see what she did, and there's I think there was a factor of 10 error there. Maybe she forgot the constant g. Okay, and that solves problems pretty quickly when you look at the answer keys. I had to block the background because it's a photo roster, but photo rosters are really good to use, so you know who you're talking to. It's a good way to learn your students' names, so you can put a face with each of the names that you're talking to. All right, now this is the third problem in a homework series, the third and final problem in a homework set, and it's kind of like the other two. It just gives you fewer divisions of the problem. It wants you to figure out more of it on your own. So here I'm trying to prompt the student to get her to think back to the previous questions. How should we find the center of mass velocity? What have we been doing in the previous questions? I gave her a bit of time to think about that. Okay, that sometimes you need to add some information of your own if they're not saying what you expected them to say. And we're trying to, in this problem, as in the previous problems, we're trying to look at the simplified point particle system. That will allow us to find the translational kinetic energy and thereby solve for V. Now in this problem, it doesn't explicitly tell you how far the center of mass has moved, so you need to figure that out. Notice again, I'm trying to prompt the student to add more. Giving some hints. And it looks like the student just doesn't quite know what to do here. So it's good to ask if you've waited a while if they're really stuck, and then you can explain some things. But it's always good to give them the chance to see what they know. Here we get to the question of how far does the center of mass move? She has the basic formula down, but I anticipate that one of the problems in this this question that students we'll be considering is how far did the center of mass move. It's good to make a little diagram so you can see why. The mass started out as a jumbled heap, and then the center of mass is in the middle of the chain. So I drew a vector indicating how far that chain moved. And then since it seems to be necessary to label the diagram here. Sort of fixing my diagram a little bit, making it cleaner. And probably from there on out, she'll be able to figure out the rest of it. So you don't always need to do the entire problem. Just get them started. Now in this one, the student is going to ask about a multiple choice type question, of which there are many in WebAssign. So it's good to try to think about your teaching method for those kinds of problems. So I opened a new whiteboard, and I'm going to copy in the multiple choice part that he's talking about. I always ask them what they think the answers are first. And if it's a sufficiently complicated question, I'll mark which of those boxes that they thought were the answers. But I always like to get their input first. Okay, so he gave his guesses here. This is a sufficiently simple question that I didn't bother marking each of the choices because we can go through them pretty quickly. And I looked at the answer key there, notice, just to make sure I knew what the answer was. Again, it's not cheating. It just makes it faster for you. Right, and the answer to this question is that a point particle only has translational kinetic energy. So I want to make sure he understands that before we go on.